All right, lesson 10, division by zero, exchange of factors in multiplication, and conversions of area. I'm going to talk about first the division by zero. When we have a problem like this, 8 divided by 0, 14 divided by 0, anything divided by 0, it's not possible to divide something by 0. Suppose here we have a shape, and we want to divide it by 0. You can't divide by 0. Dividing by 0 is not possible, therefore the answer is undefined. And that's how we would solve something that's divided by 0. The solution is undefined. If you take a 0 and divide it by 8, this means you have nothing and you divide it into 8 parts. If you have 8 parts and there's nothing in every part, then you have nothing. So 0 divided by 8 equals 0. But if you take 8 and divide it by 0, if you're trying to divide by nothing, then it is undefined. The next thing in the lesson, we have some simple division problems where we need to first of all add or subtract. So let's solve the numerator. Negative 3 minus 2 is negative 5 over negative 2 plus 8. That gets us positive 6. Minus 6 is 0. Negative 5 divided by 0, we can't divide something by nothing, so it is undefined. And for this one, negative 8 plus 6 gets us negative 2, plus 2 is 0 divided by 8 minus 4 is, oh boy, 8 minus 4 is 4, minus 4 is 0, so 0 divided by 0. So this is not 0 because we're dividing by 0, it is undefined. Nothing divided by nothing. Okay, that's a strange one right there. And then looking at multiplying. When we multiply numbers together, we can multiply them in any order. If we go 3 times 4 equals 12, that's the same as 4 times 3 equals 12. It doesn't matter which order we put the 3 and the 4 in, we'll always get 12. So we can switch these numbers all around. And even if we have a long string of them, if we've got a 4 and a 1 and a 4, we can multiply them in any order, does not matter. Let's just multiply from left to right, that's the simplest. So 4 times 1 is 4 times 4 is 16. And then is it going to be a positive or a negative? So we're starting here with a negative. This negative sign changes it to a positive. This negative sign changes it back to a negative. And this negative sign changes it back again to a positive. So we're going to have positive 16. As a rule, if there's even negative signs, if you've got two negatives, you're going to have a positive. If you have 4 negatives, you're going to have a positive. If you have 3 negatives, then you're going to have a negative answer. So as a rule, count up and see if you've got an even number of negative signs, then your answer will be positive. If you have an odd number of negative signs, your answer will be negative. Doing this one, 2, 6, 10, and negative 2, I'm just going to work it from left to right. It'll probably be as easy as anything. We could work it in any order. But if we go 2 times 6 is 12, times 10 is 120, times 2 is 240, and we've got 1, 2, we've got an even number of negative signs, so that's a positive. You can also think that it's negative, and this keeps it negative, and this negative flips it to positive, and this is positive, so it stays positive. To prove that we could work it either way, we go 2 times 10 is 20, times 6 is 120, times 2 is 240, positive 240. Now the last issue that we have, the last thing we have to talk about is conversions of area. So we have a problem where it says if we have here where we have used 2 unit multipliers to convert 44 square miles to square feet. So we're going to go square miles to square feet, and we're going to start with 44. So 44 over 1, and I'm going to write square miles up here. And what we're looking for is going to be square feet over 1. So we're starting with square miles and we want to go to square feet. What unit multipliers can we use? First of all, let's go for miles, and they want us to use 2. Okay, because we don't know square things, I didn't save enough space here. Let me do a little erasing. I'm going to move this guy way out to the end, because when we use 2 unit multipliers and we're squaring it, we need to use every multiplier twice. Maybe that's what they're talking about. Yeah, they probably are. Let's see. Square feet over 1. So square miles. How many feet are in 1 mile? There's 5,280 feet in 1 mile. So we're going to put the feet on the top, 5,280 feet in 1 mile. And since this is just length and this is area, this is talking about how much area we have, we need to put this twice, 5,280 feet in 1 mile. And then we'll have square feet, because this is feet and this is feet, and we want square feet. We want feet times feet. And this is our solution. This is what we need to do. Go 4 times 5,280 times 5,280, and that is our answer. 1 times 1 times 1 times 1 is 1. So our solution could be 4 times 5,280 times 5,280. So that is the answer. And that would be a correct way of writing it, just 4 times 5280 times 5280. We're going to do this next one as well. Use 2 unit multipliers to convert 3,500 square centimeters to square meters. So here we're going square centimeters to square meters. And we've got 3,500. This is centimeters squared, and we want to go to meters squared, and we're going to use 2 unit multipliers. Centimeters to meters, there's 100. There's 100 centimeters in 1 meter. Since we've got centimeters on the top, we need to put our 100 centimeters on the bottom. You can see up here that we put the miles on the bottom. So these 2 miles on the bottom cancel out this label of miles, and these feet and this foot adds together to make the square feet. So here we're going to go 1 meter on the top to 100 centimeters, 1 meter to 100 centimeters, and that's going to give us both these centimeter labels cancel out this centimeter squared, and 2 meter labels equal a meter squared label. And then we just multiply this straight across, and we get, I'm going to write mine out here because we need to put something on the bottom. 3,500 over 100 times 100 meters squared. So this answer works as the answer. If you would like, you could solve it on out, and you go 100 times 100 and get 10,000